Okay, this video is on probability and odds. And mainly this is just going to be vocab. We'll look a little bit at using them, but probability, probably all seen before, but when we talk about probability, we talk about outcomes. And an outcome is a possible result when you conduct an experiment. So let's say, for example, I'm rolling just a regular six-sided die. Then my outcomes are that I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Those are the possible outcomes when I roll just a regular die. Okay? If I were flipping a coin, the outcomes would be either heads or tails. That's all an outcome is. An event, when we're talking about probability, is the outcome that we want to happen. So, for example, I could say that I want my event to be rolling a 2. Or I could say I want it to be rolling an even number. Something like that. And so the way that we actually write that in probability, if I knew I was talking about rolling a die, then, and I wanted to talk about the probability of rolling a 2, I just write P, meaning find the probability, and then in parentheses, I write the event. So P2 would be the probability of rolling a 2 if I knew that I was rolling a die. Or if I knew I was flipping a coin, I could write P and then put heads in there. It'd be the probability that I'm going to flip a head when I flip the coin. So that's how we actually write out probability. The favorable outcomes are all the ways that what you want to happen can happen. So if I'm talking about, rolling a die again, sticking with that, and I want to roll a 2, then I have one favorable outcome, which would be a 2. If I was looking at rolling an even, then I would actually have 3 favorable outcomes, because I could get a 2, a 4, or a 6, and they would all fit the event. And so in that case, I'd have 3 favorable outcomes. Okay? And so the way that you find the probability of an event is you take the number of favorable outcomes, what we want to happen, over the total number of outcomes. So, sticking with the die, if I wanted the probability of rolling a 2, there's only one favorable outcome. All I could do is get a 2. If I don't get a 2, I didn't get what I wanted. So I only have one favorable. There are, set up top here, there are 6 possible outcomes when I roll a die. So my probability for rolling a 2 would be 1 out of 6. If I'm flipping a coin and I want to know the probability of getting a head, then it's going to be one way I can get heads out of 2 possibilities, either heads or tails. So that probability would be 1/2. So notice that because it's the number of favorable outcomes over the possible number of total number of outcomes, it's always going to be a fraction. The lowest it could be then is 0. Okay, if I'm rolling just a regular 6-sided die, the probability that I'm going to get a 10 would be 0. It's impossible to get a 10 on a die. The highest that the probability could ever be would be 1 whole. Like if I wanted the probability of rolling a number less than 10. Well, there are 6 numbers on the die that are less than 10, so they would all be favorable outcomes in that case out of 6 possible outcomes, and the probability would be 1. So probability is always written as a fraction, and so it's always going to be somewhere between 0 and 1. Okay? Now these probabilities that we're talking about are what we call theoretical probability. Theoretical probability is what's supposed to happen. So in other words, if I roll a die 6 times, I'm supposed to get a 2 once. I should get 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6. Theoretically. We know, though, if we actually roll a die 6 times, we probably aren't going to get one of each. Probably something's going to come up twice. And so that is what we call the experimental probability. That's what actually happens when you conduct an experiment. So let's say I roll this die 6 times. Okay? First time, I get a 2. So I'm going to record what I get over here. So I get a 2. Let's roll the second time, and I get a 1. Okay. And the third time, see, I got a 3. Fourth roll, a 5. So far I actually am getting one of each here. See if I get a 4 and a 6 now on these last 2 rolls, or if something repeats itself. I got another 3. So I know now my theoretical probabilities are not going to hold up. You'll see what I mean in 1 second. The 6th roll here is another 3. Okay? So what this means then, if I want to look at the experimental probability for rolling this die these 6 times, the probability of rolling a 1, I got 1 of them out of 6 rolls. So that probability actually matches the theoretical probability. I did get 1 out of the 6 rolls. Probability of getting a 2 also matches. That was 1 out of the 6 rolls. But here it's different. The probability of getting a 3, I've got 3 of them out of my 6 rolls, so that probability is actually 1/2. I never got a single 4, so that probability is 0. Probability for a 5 matches the theoretical. I got that once. That is 1 out of 6. And I never got any 6s. So that probability is 0. So a couple of them, 1, 2, and 5, did match what the theoretical probability was, where 3, 4, and 6 were different from the theoretical probability. So just, again, the difference, the theoretical is what's supposed to happen, the experimental is what actually does happen when you do your experiment, with the idea being that the more and more you do this, the closer and closer it's going to get to the theoretical. So if I roll this 100 times, it's probably going to come out a little bit better and be closer to having all of them be 1 out of 6 when I reduce it. If I rolled it 1,000 times, it's probably get even closer, 1,000,000 times even closer. So if you do it a bunch of times, eventually it is going to match up with the theoretical probability. But you got to do it a bunch. Okay? Now, odds are very similar to probability, slightly different. Odds, instead of being a favorable over the total outcomes, it's your favorable outcomes over the unfavorable outcomes. So if I wanted to find the odds of rolling a 2, then I have still 1 favorable outcome, but instead of 6 total outcomes, I have 5 unfavorable outcomes. If I roll a 1, a 3, a 4, a 5, or a 6, those would be unfavorable. And so the odds, it gets very confusing because odds look like probability. It's still written as a fraction. Difference here is you can actually have improper fractions. Okay? if I wanted the odds of rolling a number greater than 1, then I have 5 numbers on a die that are greater than 1. So my favorable outcomes, I'd have 5 of them. I would only have 1 unfavorable outcome. So my odds would actually be 5 over 1, or 5. Where probability can never be bigger than 1. So that's one big difference in odds. So you got to be really careful. It's easy to mistake these because they're so similar. So you've got to be really careful when you're doing them. Now we can also use probability to help us make predictions on things that will happen. If Joe makes 80% of his free throws on average, and he gets to shoot 20 free throws in a game, how many would you expect him to make? Well, 80% is a probability. Okay? Percent means out of 100. So 80% is 80 over 100. If we reduce this fraction, we can get rid of the zeros. So I have 8 over 10. And then that can reduce to 4 over 5. So this is my probability of making the free throw. I was supposed to say making a free throw. And so I can use that to find how many I would think he's going to make in this game. All I have to do is take that probability at 4/5 and multiply it by how many free throws he gets to make. He gets to take. And then in order to multiply these, I know I've got to put 20 over 1. I can reduce, because 5 goes into 20. I can reduce that. I can reduce to 20. 5 goes in 24 times. Then when I multiply, 4 by 4 is 16. 1 by 1 is 1. And I would guess that he's going to make about 16 out of those 20 free throws. So that's how you can use a probability to make predictions about what will happen.